Today, on how it's made. Screwdrivers. Compact track loaders. Physician scales. And carbon fiber bats. Bit by bit, the screwdriver makes the life of a handyman a whole lot easier. The screwdriver first showed up in the early part of the 19th century. It evolved from a flat-bladed bit used in a carpenter's brace, and its invention was a definite turning point. These trusty tools come with different bits to fit a variety of screw heads. All you have to do is apply the right torque, and it's mission accomplished. The job of making screwdrivers starts with coils of specially formulated steel. Wheels straighten the thick wire, and then it travels through an aperture. On the other side, a machine rocks back and forth as it cuts the wire to length and forces it through 4 dies. The first die narrows the steel to the required diameter. The others form a hexagonal bolster partway down. This bolster will allow a wrench to be applied to the screwdriver to increase its turning power. A quick shower washes away the lubricant. And these screwdriver shafts are ready for inspection. The technician examines them for defects and measures the length and the dimensions of the hexagonal bolster. Once he confirms that everything is to specification, the screwdriver shafts head into a machine that will transform the tips into a slotted shape. At the first 2 stations, the press flattens the tip. The third one trims it and stamps the part number onto it. The flat blade is probably the most common of screwdrivers. Its chiseled tip turns a standard slotted screw. After the screwdrivers are heat-treated to increase their hardness, they sand the tips to shave off 1/10 of a millimeter. They confirm that with this slotted guide. Then they insert the screwdrivers into a different slotted device. This one shuttles them over to a grinding wheel. This wheel trims them to their final dimensions. Visually, the change is subtle, but this fine-tuning will make a big difference in the screwdriver's performance. Now, they twirl in a machine that blasts the tips with a mild abrasive. This texturizes the surface to allow this screwdriver to really grip a screw head. The texturized tip is the one on the right. Over at another station, a different kind of screwdriver is taking shape. This is a Phillips. Its tip has a beveled cross point to correspond with the Phillips screw. This machine carves ridges into the bevels of the cross point to give it extra gripping power. A press then slams into the other end of the screwdriver to create flanged grooves. These grooves will allow them to lock the screwdriver shaft into its handle. It's time for some positive vibrations. This vibrating feeder causes the screwdrivers to chafe against each other, and the action removes any waste material. After they texturize the cross-point tip, it's over to a laser machine. It etches the part numbers onto these polyurethane handles. And now for the gripping part. The assembler attaches the handle to the screwdriver blade. He then places the screwdriver in a machine that applies mechanical force to solidly entrench the shaft in the handle. With the screwdrivers now on a tray, they move through a curtain of plastic. A machine heat seals the plastic around the edges. The loosely wrapped tray then enters a special furnace, and the heat shrinks the plastic around the tray to neatly wrap up this job. It has taken several days to make these screwdrivers, and now they're ready for the twists and turns of any job. Compact track loaders move materials like dirt, gravel, and even snow into a dump truck or any other type of machinery. The rubber tracks give them the traction to work hard while treading lightly over soft ground conditions like grass. Compact track loaders can be used year-round. Compact track loaders give a smooth and stable ride over all sorts of terrain. Their rubber tracks and suspension allow them to turn on a dime and work in places where other machines couldn't. To start, technicians attach 4 sets of mid-wheels to a frame rail. The wheels are made of plastic and rubber. Then they assemble the axle suspension, using rubber cords so the wheels can flex up and down. They tighten the bolts and mark them as done. After they attach 2 more sets of mid-wheels, what's called the frame rail assembly is complete. Technicians then attach a turnbuckle to the frame rail. The turnbuckle will be used to tighten or loosen the rubber track. Next, they put together the drive sprocket assembly, the part that drives the track. They put a drive motor into a housing, add the sprocket assembly, then put on a heavy-duty bearing. Finally, they install a support plate, which completes the drive motor assembly. A technician then mounts the drive motor assembly onto the frame rail assembly. Technicians install the rubber track onto the frame rail assembly. A little lubrication makes the track go on easier until its molded lugs interlock with the drive sprocket assembly. Next comes a larger idler wheel, which they install at the end of the track, securing it on the axle. He tightens the turnbuckle to give the rubber track the correct tension, completing the undercarriage assembly. The track loader will ride on 2 of these undercarriages. A technician installs the machine's main suspension onto the chassis, then connects the hydraulic valve assembly. It's the hub to which they connect all the hydraulic lines and hoses used to control the machine. Using a crane, the technician mounts the engine to the chassis. Once the engine is secure, he puts on the integrated fuel tank. He installs a hydraulic cylinder and connects its 2 fluid lines. 1 cylinder goes on each side of the machine. They're used to move the loader bucket up and down. He then connects the undercarriage assembly to the chassis, using an undercarriage pin and a pneumatic wrench to secure it in place. A technician now installs the loader assembly, the part that holds the bucket or other attachment. Once installed, this machine can lift up to 2,800 kilograms. He secures the assembly in place using heavy-duty pins. Then technicians install the operator station that helps protect the driver from the elements and from debris. A technician makes sure the loader arm works properly, then drives the track loader on a treadmill to test all the systems. He runs the engine at full speed until it reaches the appropriate operating temperature. This shows that everything is working as it should. Finally, he affixes the company logo. compact track loaders are strong and agile machines. They work just as well on dry surfaces as they do in wet and muddy conditions. Stepping onto the scale at the doctor's office is a moment of truth not everyone enjoys. Little has changed in the simple design of these scales since the early 1900s. Cast iron has given way to steel and aluminum. That means they've actually gotten lighter over the years, unlike some of us. This scale compares the weight placed on the platform with a standard weight, known as a poise, that slides along an off-center weigh beam until it balances. A punch press forms sheet steel into the head or top of the scale's column. Workers form the column from another piece of steel, using this press brake. Then they spot weld the head and column together. Another machine stamps out lengths of steel that will form the frame for the scale's base. Workers use the press brake again to bend both sides of the steel lengths. Then they fold it by hand to form the frame. They clamp the frame onto a base, and this robot welds them together. The robot moves on to weld other components to the scale, such as the lever mechanism and the base plate. Now workers place steel bearings at each corner of the base where the lever mechanism will rest. Then add the base frame. Next, they install the long lever, then the short lever. A C-clip joins them together. Once it's right side up, the lever mechanism hangs off the platform. The columns receive a coat of electrostatically charged paint that evenly coats the metal for a flawless finish. Once it's dry, a machine silk screens the brand name onto the column. Now for the final assembly. A worker inserts a 1.2-meter steel rod that will tie the weigh beam to the levers. He works the rod up through the column. Then, at the column's head, he screws it to the weigh beam's shelf. Another worker hammers the large poise into position on the weigh beam, then the smaller poise. They screw onto the beam in two parts so they can glide freely. She applies a gauge onto the beam that indicates the weight measured in pounds, from 0 to 350. Now she takes a zero adjustment screw and spring loads it onto the beam. This allows the beam to balance when the poises are set at 0 and the scale is unweighted. A retaining ring holds the screw in place. At the assembly line, workers fasten the scale's column to its base. They cover the pivot to protect it from wear and set down the weigh beam that balances on it. Then they connect it to the steel rod that comes up through the column from the base. Once the weigh beam connects to the lever mechanism at the base, the scale is functional. Now it's time to make sure it's accurate. Each scale goes to a weigh station where workers check the readings in 20-kilo increments. If the readings are off, workers go back and remove some lead from inside the large poise so the scale calibrates perfectly. Just a few grams of lead can make all the difference in accuracy. Finally, they place a plastic cover over the working parts, and the scale is complete. When the competition is stiff, sometimes it helps to be a little flexible. And that's the idea behind the carbon fiber softball bat. Manufacturers can tweak the stiffness of carbon fiber to produce a bat with some elasticity. It's a striking innovation. Carbon bats are a high-tech way to improve your game. Incredibly, these hard-hitting bats start with pliable sheets of carbon fiber infused with a special resin. They crisscross the sheets and then iron the side with the paper liner to melt the layers at the seams. A hot steel roller then applies some serious pressure to fuse the carbon fiber layers together. They slice it to size. Now they peel away that paper liner and spiral the carbon fiber around a steel bat form. By changing the angle of the weave, they can fine-tune the bat's elasticity to a league's specifications or to an individual player's performance level. They wind polypropylene tape around the carbon layers to squeeze out the air between them. They bake the carbon in an oven for 2 hours. This cures the resin impregnated in the carbon, so the many layers become one. After they slice away the tape, they slide braided weaves of carbon and fiberglass over the fused carbon form. They secure the braided tubing with tape. They pull a layer of thick carbon over that, followed by a super strong synthetic weave called aramid. One last taping, and this softball bat is ready to take shape. They place the carbon-wrapped forms in a mold. As the mold closes around them, they prepare an epoxy resin. They then inject the resin into the mold. It permeates the many layers wrapped around the steel form. The mold applies hot pressure to bake the layers together and define the contours of these bats. It takes just a few minutes in the mold to transform the many layers into a solid bat. This 5-ton puller now extracts the steel form on which the carbon bat was built. They use this pneumatic equipment to test its flexibility. A lathe now spins the bat as a cutter moves in and carves the hardened resin base into a knob. The knob on the right now meets league specifications. Now this carbon bat goes for another spin, so they can sand it from every angle. They dip the bats 2 at a time in black primer and hang them to dry. The bat then takes on a more colorful appearance with a variety of spray paints. They transfer decals with production information onto the barrel of the bat. And a laser burns the company logo and serial number into the painted carbon. They cap the bat by press-fitting a polycarbonate plug to the barrel. Resin completes the seal, and they add extra to adjust the bat's weight to league specifications. They pump the resin in through a hole in the knob, and it flows up to the barrel plug. Then they weigh each bat to verify that it's within an acceptable range. Using a hydraulic ram, they drive a steel pin into the hole in the bottom of the knob to achieve the correct balance point. And it's time to wrap this carbon bat with synthetic leather, making it easier to grip. These high-tech bats are now ready to team up with raw talent, and they could blow the competition out of the ballpark.